Hi, now that we already know how to perform binary classification, in this session I want to go ahead and discuss multi-class classification. That is when we have more than two classes. Let's consider an example. If there is a tournament to be played between India, Australia and England, and we have to build a machine learning model which is able to predict who is going to be the winner, right? So our winner can be one of England, India and Australia. So there are three classes, right? So in this case, what we do is instead of building one machine learning model, we build three models, right? Since there are three classes, I'll be building three models. So first model will be predicting whether the winner will be England or not England, right? That whether the winner will be England or it will be Australia or India, right? England or not England. My second model is going to predict whether the winner is going to be Australia or not Australia. And similarly, my third model will be predicting whether it will be India or not India, right? So I have broken my model of three classes into three models with each having only two classes, right? So for my first model, I have only two classes, that is England or not England. So I can easily perform binary classification on my first model, right? Similarly, for second model, I can perform binary classes on Australia and not Australia. And similarly for third model, India versus not India. So if my first model says probability of England winning is 0.4, my model 2 says probability of Australia winning is 0.3, and let's say my model 3 says probability of India winning is 0.45. So what we can see, as per model 1, probability of England winning is 0.4 and probability of someone else winning is 0.6, right? So as per model 2, probability of Australia winning is 0.3 and probability of someone else winning is 0.7. Similarly, in model 3, probability of India winning is 0.45 and probability of someone else winning is 0.55. Okay, so from these models, we can see probability of India winning comes out to be highest. So what we are going to do, we are going to predict that this tournament will be won by India, right? So I hope this is clear. So how we are going to implement this? So if this is my X and this is my Y, for each of the models, this is my model 1. For each of the model, my X will remain same, but my Y will be transformed to something like this. England, not England, again not England, right? My model 2 will be something like, this was my model 1, not Australia, not Australia, 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 not Australia. Similarly, my model 3 will be not India, India, not India, not India, India, right? So these are three separate models that can use binary classification to predict whether it's yes or no between England, not England, Australia, not Australia, India, not India, right? So this approach is known as one versus rest approach, right? Because each of the model is predicting one versus rest, right? Whether it is England or not England, whether it is England or it is someone else, that is rest of all. Okay, so in logistic regression there is a parameter multi-class which will be passing OVR. OVR means one versus rest approach. Okay, so I have already loaded the data set. So the dataset that I'll be using is iris dataset. So in iris dataset we have 150 rows, that is 150 data points and 4 features. I have already splitted the dataset using train test split method and random state I am passing as 1. Okay, let's check the description. So there are 150 data points and there are 4 features. And there are 3 classes, that is iris setosa, iris versicolor and iris virginica. So this is basically a data set of flowers of 3 categories: iris setosa, iris virginica and iris versicolor. Right? So out of those 150 data points, there are 50 belonging to iris setosa, 50 belonging to iris versicolor and 50 belonging to iris virginica. Right? So we have 4 features, that is sepal length, sepal width, petal length and petal width. Based on those features, we have to tell as to which category the flower belongs to. Okay. So let's first make the object of the logistic regression class. I'll be passing multi-class is equal to OVR. For multi-class classification problems, we generally pass solver is equal to LBFGS. Okay, so let's train a model. Let's check the score. Okay, so we are getting a score of 0.89. Let's do one thing. Let's change the random state property and see if it makes any changes to the score. So as we discussed in the last session, many people use 42 as the random number. So indeed it is giving us a good score, but there is no reason to think why it should give us a better or a worse result. This idea of 42 is just based on one of the books by the author Douglas Adams, right? So I mean many other values can give you the same or even better result. Let's consider some other random state. So let me take 10. So it's giving the same result, right? So don't think that 42 is a very magical number and it's going to give you a great score. It's nothing like that. It's just a very normal random number. Okay, so I hope now it is clear how multi-class classification works in logistic regression. See you in the next session. Thank you.